This is an example of using Pythagorean theorem, and we're going to look at the context of simplifying radicals. So Pythagorean theorem, to review, is a squared plus b squared equals c squared. A and b are the legs of the triangles, and c squared is the hypotenuse. That's our long side of your triangle. So that's the most important to remember, that c is your long side, a and b, it doesn't really matter which one's which. So if I'm given a problem where my hypotenuse is 7 and let's say the short leg is 3, we want to find this other leg in a right triangle. So let's call this 3a. So 3 squared is 9. 9 plus, let's call our missing side, the unknown, the b squared. And this is equal to our hypotenuse squared. So c squared, 7 squared is 49. So to isolate our b squared, we need to subtract 9 from both sides. So this shows us that b is equal to, b squared is equal to 40. 49 minus 9 is 40. To keep solving this problem, we need to remember what the inverse of squaring is. So to get rid of squaring, the other side of squaring is taking a square root. So we take the square root of both sides. And that gives us b equals the square root of 40. Now, is this in simplified radical form? Well, we need to recognize whether 40 is a perfect square and can be reduced, or does 40 have factors that are perfect squares. So if you recall your squares, they're pretty easy to think about if you just run through the numbers in your mind and square them. Just count from 1 and count up until you get as high as you need to be. 1 times 1 is 1, 2 times 2, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. You can keep going, but I have exceeded the 40. So the square root of 40 falls in between 36 and 49, so this value will be 6 point something. It falls in between the whole numbers 6 and 7 if I look at square roots. So it's not a perfect square. I would have come across it as I square these numbers and make this list. So there's two thought processes involved in simplifying a radical. So one method is to break it down into its prime factorization. It's prime factors. So you can start anywhere, where whatever is convenient. You can use the rules that you know of how to tell whether a number is a factor of another number. I can say, well, 40, I recognize that as 4 times 10. And that's fine. And if you want to further break those down, because those aren't prime, you can say that is 4 is composed of a pair of 2's, and 10 gives us a 2 and a 5. So the ingredients that make a 40 by multiplying, if I break it down into its parts, we have a 2, a 2, a 2, and a 5. So these are the end nodes that we look at. So we're looking for a pair. Well, we have a pair of 2's, and we have no more pairs. So for every pair that we see, for every 2 numbers, you bring that outside once, outside your radical. And the remaining numbers, you multiply those back together and leave those inside the radical. So our simplified radical form on this, we pull the 2 out, and inside we have the 10. So 2 root 10. So I could have done this in another way. I could have taken the 40 as 5 times 8. Now 5's done, and 8, 4 times 2, and a 2 times 2. So I have a 5, a 2, a 2, and a 2. Those are the numbers I'm looking for. And there's my pair of 2's. I get the same thing no matter how you break it apart. The other way is to recognize, look for 40, say what goes into 40. So looking from 36 and smaller, are any of these a factor of 40? 36 is not, 25 is not, 16 is not, 9 is not. I see 4 is a factor of 40. And we saw that as I broke it apart both here and here, we saw the 4. So 4 is a perfect square. So with this method, I would say that the square root of 40 could be rewritten as the square root of 4 times the square root of 10. So I'm just looking at a perfect square that's a factor of 40. And I know the square root of 4 is 2, so I get 2 root 10. So both of these methods get the same result. And depending on the problem, you may want to choose which method works better in a certain context. This works faster when you can use it, but if you see a large number that you don't recognize, it's always good to break it apart by its factors that you recognize. Review a couple rules of recognizing factors. Remember, if a number is even, 2 goes into it. If you add up the digits in a number, like 0 plus 1 is 1, 3 does not go into 1, 3 does not go into 10. So that works for any large number. So if I were to try, I'll just make up a number 1357. So I just add up these digits. So 5 and 7 is 12, 15, 16. So we have 16. Does 3 go into 16? You could even add up to 16 if you want. 6 and 1, no, that doesn't work. But if I put a 2 on here, 21,357, does 3 go into that? But I can even look at it. The 2 and the 1 makes a 3. There's a 3, 5 and 7 makes it 12. 3 goes into that. So 3 will go evenly into this number. So that's a very useful way of seeing if 3 goes into a number. 5 will go into a number if it ends in a 0 or a 5. And from then on, it's just a matter of looking at your prime numbers and starting with, say, 7, and try 11 and 13 and on up. So use those tools to break down numbers and recognize whether or not they can be simplified.